Okay, so our last part on Intro to Solids is going to be talking about solids of revolutions. So the solid of revolution is, imagine you take an object and rotate it about a line. It's the 3D shape that's created when that happens. So here's a little GeoGebra demonstration here. So we have this right triangle and it's fixed on this axis here, which looks like the kind of the height of the triangle. And if you just rotate it about that axis, you can see that it creates this kind of cone shape. Alright, so there's the definition of the solid of revolution. So I wrote it as a 3D figure created when you rotate a 2D figure about a line. And that line that you rotated about is called the axis of symmetry. So I showed you one example, and I'll show you more with that GeoGebra GIF. But I think before I give it away, I think you should try these 4 on the bottom. And try to figure out what the solid would look like if you rotated those objects about each line. So now would be a good time to pause the video, take a couple minutes, and try those 4 problems. Okay, so the first one, a rectangle rotated about a line, would create a cylinder. So these shapes would rotate around, and the cylinder had the same height as the rectangle, and like the base of that rectangle would be the radius of the circle. Here's a better visualization of that. So you take a rectangle and you rotate it about a line. Notice how if you complete that rotation, it makes a cylinder. And as you change the height of the rectangle, it's going to change the height of the cylinder. And as you change the width of the rectangle, it's going to change the radius of the cylinder. Okay, for the next one, you would get a cylinder, where the radius would be 4 and the height would be 9. For the third one, as similar to the first GIF I showed you, you would get a cone that had a radius of 2 units and a height of 5 units. And for the last one, if you take a circle or a semicircle and rotate it about a line, you would get a sphere. And a sphere is like a 3D version of a circle. A circle has, now it's kind of hard to draw a sphere, but a circle is the set of all points that are equidistant from the center of the circle in 2D. In 3D, that's a sphere. So if you think of where you're sitting right now watching this, and you think of every single point like 5 feet away from you in 3D space, that all those points together would make a sphere. And here's another representation of it. So now we're going to take this circle and rotate it about the axis of symmetry, and notice how it makes a sphere. Okay, so the last question is, what happens if you take a 2D figure and it's not attached to the axis of symmetry? So what do I mean by that? Alright, so let's take this line, and let's take this object right here, and we're going to rotate it about this line in 3D space. Alright, how is it going to differ from all these examples where the figure is attached to the axis of symmetry? So think about it, pause the video, maybe sketch a picture of that example or another example. Right, you can have, maybe it's like just a rectangle out here that you're rotating about this line. So what happens when it's not attached to the axis of symmetry? So if you took a circle and rotated it about a line that it wasn't attached to, it would create this sort of like ring type of scenario. So when it's not attached to the axis of symmetry, you're going to have like some space in the middle of this object. And let me show you another example on the internet that's probably better than my first grade illustrations. Okay, so here's a cool example I found on mathbits.com. Nice website you might want to check out if you ever need help. And so that's kind of like what it would look like. And if we look at this here, like if you took like a ring or like a half a donut and rotated about a line, you would have a sphere with the hollow center. So just kind of interesting things to think about. And these ideas are really important when you get to calculus, so it's good to start thinking about them now.